All right, so we've understood local area network, wide area network, and now we're going to cover this concept called a metro area network. And you'll generally see this in your data center. So users eventually are trying to connect to a location that has two different routers, for example, which in turn connect to these really high-end switches, which, by the way, you'll need to draw this out, so make sure you're taking notes because your trainer's going to have you draw this. So they'll be connected in some kind of redundant way like this, and you'll have all kinds of other switches here. So this is where all of your servers are going to reside. So think of all the websites that you connect to, your database servers, your various applications like email, which the most common one is called Exchange. So all this stuff is living here inside of your data center. Data center. So a data center is just a bigger version of one of these branch offices, right? Because your branch offices only have like one router and maybe a switch, or maybe, you know, a bigger branch office might have more switches here, but they're generally way smaller than a data center, and a data center is just a place where all of your servers are. So in a larger Fortune 1000 environment, you'll have more than just one data center. So you might have a data center in Plymouth, Minnesota, and you might have another data center in Chaska, Minnesota, let's say. And so that data center also has all sorts of switches, and there might be hundreds of switches with thousands of servers, and these switches are all interconnected to each other. So all the servers that are sitting here also want to talk to all the servers that are sitting here, because they'll have things like replication set up where in the back end they'll need to talk to each other. So there's generally this fiber optic environment where you can basically lease fiber from some kind of provider. So you'll have a ton of bandwidth between data center 1 and data center 2. So think of this as an entirely different location. So this might be like a 10 gig set of links between these data centers, and this is referred to as a metro area network because it's not separated by a WAN, but it's just separated by fiber, and that's basically what makes it a metro area network. And it's generally not like spread across the entire country. It's usually within the same state or an adjoining state. So as you can see, we're just adding pieces to this big puzzle, right, of what is actually at one of these Fortune 1000 companies. So at this point, we've covered that we've got a branch office here, a bunch of branch offices here. They're connecting to this private network in order to access all of the different applications like your emails and everything that are at these data centers that are connected to the MAN. But where the hell is the internet, right? So the internet comes in an entirely different circuit, right? So somewhere over here you're going to have a internet service provider, which is different from your MPLS provider, right? So that's for your private circuit. So this is the public internet, and you're going to have a router or two routers at your data center that is going to have a connection to here. So in a larger Fortune 1000 company, they'll want to control everything, so they will have these things called proxy servers that are here at the data center, and when you try to access the internet, what's actually going to happen is you're going to go through your branch office over the MPLS network and then back into the data center through the proxy server and then out the internet to, you know, Google or wherever you were trying to go. And the reason you do that is because they can control the policy on the proxy server to make sure that users are, you know, not able to go to inappropriate sites or things of that nature, because at a larger company there's a huge liability with, you know, controlling who can access what. And that's why you typically won't see something like this where you have a branch office with an internet router right here. So you won't have internet at each branch office, because that would be a lot to manage, right? Imagine having 1,000 internet connections at 1,000 different locations. That'd be a nightmare to manage, and it'd be hard to control the policy. So for that reason, in a larger company, the internet is hosted out of the data center, and all of your connections go through your private network first, and then out the internet at the data center. Okay, so now we're going to cover the need for virtual private networks. So at this point, we've covered the fact that you have this entire network that you utilize when you're at the office, right? Because at the office, you're accessing servers that have these IP addresses on them, and we're not going to go into all the theory about IP addresses, but there's this range of IP addresses that you use, which is 10.something.something.something. This range of IP addresses is absolutely not allowed over the internet. So you can't just go home and fire up your computer that is connected to Comcast or CenturyLink. You can't just fire that up and say, I'm going to go ahead and connect to this 10.IP address for my server back at the data center. When you try to route over that to your ISP is going to say, you're crazy, you can't do that. So you need to have a way where you can connect from the internet at home and somehow still get access to this private IP address over here. And the most common way to do that is through a virtual private network. So what you're going to do is you're going to have a piece of software on your computer called Cisco AnyConnect. And this is a VPN software. And what you're going to do is you're going to connect over the internet to a VPN server, so to speak. And that's going to be a Cisco ASA firewall, right? So you're going to connect to a Cisco ASA firewall through this VPN software. And what that basically does is it basically builds this kind of secure tunnel, which I'm going to draw with this little circle right here, or this long box right here. So even though I'm on the internet, I can connect to the ASA, and at that point I'm going to have this encrypted tunnel, is what they call it, right? So you're going to have this encrypted tunnel, and then through this tunnel I can now access all of my stuff that's actually over here, all of my servers. So even though I couldn't connect to 10 dot whatever directly over the internet, once I connect through my Cisco VPN, I can now connect to whatever I want to in my internal data center, because I've kind of built a private connection over the internet through my VPN software. All right, so you have on-premise versus cloud. And this is a really mystifying concept for a lot of people, and it's a really buzzwordy thing that you hear all the time, like different cloud services. So cloud services are things like Amazon Web Services or Microsoft Azure are the two most popular things. On-premise is just literally saying you manage your own stuff. So you might have your Microsoft Active Directory. So think of this as where all your users are set up and permissions. You might have Exchange email. And you'll have a bunch of other servers, right? Like web servers and database servers and all kinds of stuff. So when it's on-premise, it just means that your own internal IT staff manages all of it. Cloud is just literally saying that you had some of these servers that used to be in your internal network is now moved over to here. And the theory is that the cloud service will make it easier to manage your infrastructure because you don't have to have the burden of managing all your servers that you once had in your data center, and you don't have to have as much staff to manage your environment. So it's kind of true, because at the Amazon Web Services level, you'll see that there's a lot of automation. Where they've got all kinds of nifty web interfaces where you can create servers and applications arguably a lot faster than you could with your own internal staff, because this is pretty sophisticated, right? Same thing here. But the thing is, with the cloud services, you have to pay a monthly fee. So, for example, if you have Microsoft Office 365, what this is basically Active Directory, Exchange, and other core Microsoft applications, all kind of bundled into one thing. But you pay a monthly fee, let's say, $5 per user. So you pay $5 per month per user. So it sounds great, but if you have a lot of users, so let's say you have 10,000 people in your company, you're now paying a ton of money per month. So you're paying in the millions per year, right? So you're paying a lot of money per year to have the freedom to have it hosted here, versus having to deal with supporting Exchange email natively, supporting Active Directory natively. So natively just means you host it yourself over here, versus them hosting it for you over there. So there you're paying a monthly fee. Here you don't pay a monthly fee, but you do have to pay fees to cover cooling and rack space in your data center, and potentially more IT staff to manage all this stuff. So you kind of have to pick your poison. As the business, they may choose to go over to Amazon or Azure to make it easier to manage your stuff, because it's all over in the cloud at that point. But at the same time, the cloud is accessible through the internet. So depending on where your users are, they're going to be obviously on some kind of network, and they might be over in Illinois, and this Google site or the Azure site might be in California, or whatever that case may be. So you are going to have to go a further distance to be able to get to this stuff, right? So you definitely add latency. So even though it sounds great and you're basically, using all these fancy automation tools over here, you can get things up and running faster, and you just pay a monthly fee. A lot of people don't think about the fact that when you have everything inside of your own data center, the distance to get here to your own data center versus, and remember, this data center is accessible through a private network. And this private network has much better latency because it's generally shorter and you control it more, versus the internet is completely unknown and you have no idea how many different internet service providers you're going through before you go from here to here. So there's definitely a latency difference. So it's highly debated right now, but you just have to kind of understand at a high level what the differences are between cloud versus on-premise.